In this video, we'll go over test 1. Now, the order of questions might be different than yours, but it should have all the questions here. So I'm not going to go over the short answer ones which already have the answers because that is pretty self-explanatory. So let's get to some of the math problems then. So at what temperature, if there is a reaction spontaneous, if enthalpy has a value of A kilojoules per mole and entropy is B kilojoules per mole, right? So everybody got a different value of A and B. So I can just do this using our variables. So we have delta G equals delta H minus T delta S. The thing to remember about this is if a reaction is negative, delta G that is, it's spontaneous. So I'm looking for, okay, when is delta G 0, right? So I'm going to solve for when delta G is 0. And I'll tell you why I'm going to do that in a second. So let's solve that. 0 equals delta H minus T delta S. Now I'm solving for temperature. What temperature is this spontaneous? So I'm going to get T by itself. So minus delta H equals minus T delta S. Divide each side by minus delta S. And you get delta H divided by delta S equals T. All right, so when you solve this for your actual enthalpy and entropy values, you'll get a temperature where we are spontaneous. And this, or sorry, where we're at equilibrium because delta G equals 0. And we use this as a baseline to say, okay, we can now know where we're going to be spontaneous, because if we go just a little bit below that temperature or above, it depends on what sign you actually got for S and H. People might have got different signs, but that'll just tell you whether you're spontaneous or not. So you should be able to see your answer, or sorry, the answer that the computer was looking for, as this one is graded automatically. So if you see something you don't agree with, you think you did get the right answer, let me know and I can definitely take a look at this problem for you. All right, 9, pickle. What is the charge of pickle at pH 1, 7, and 14? All right, so pickle NH3 plus PiCKL ECOO minus. Remember, every peptide has a positive negative terminal. So pH 7 is what we learned the amino acids at. So that's positive, neutral, 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 positive, neutral, negative, negative. It's 0. So pH of 1. For this, we need to know our pKa. So the pKa of NH3 is roughly 9. P doesn't have 1. I doesn't have 1. C, it's roughly 8. K is roughly 10.5. L, E is like 4.5. And C is 2. Basically, when you go to low pHs, anything that is negative becomes neutral. So positive, neutral, 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 positive, neutral, neutral, neutral. So that's 2. At a pH of 14, anything that's positive at a pH of 7 becomes neutral. But we also have C here. C has a pK of 8. So when we go above the pKa, what happens is that we lose a proton. And a proton is positively charged, so C becomes negative. K was positive, so it's neutral. Neutral. E is negative. 7 stays negative. Negative. That's how we get -3 there. amine trinucleotide. So remember, I saw this error quite a bit. It's this carbon that is determining if you're DNA or not. So there's no OH there, so that's deoxy. What are the signs when water boils? Those of you who studied the previous exams should have been expecting this question. So when water is going from a liquid to gas, you're increasing entropy. That's why delta S is positive. And when water is boiling, right, you're putting energy into the system to boil that water. So you're breaking bonds. That's why delta H is positive as well. Why doesn't water and oil mix? I was really looking for one, do you know that water is the driving force of this reaction or this phenomenon? Water does not want to interact with hydrophobic molecules. It's not the other way around. Hydrophobic molecules could care less. They would interact with anything. So water cannot interact with hydrophobic molecules because they cannot hydrogen bond. So that is energetically unfavorable. Then what they'll do is they'll form a Clathrin cage to separate and push the hydrophobic molecules together. So that's what I was really looking for a complete answer. Number 12 there. 13, another multiple choice. 14, we went over this question right on Wednesday before the test. So it's a buffer. So I'm looking for what is the pKa. Hydrogen bonding. Remember, a hydrogen bond can only happen between molecules that are not connected. And the hydrogen has to be connected to an oxygen, nitrogen, or fluorine. So 1 and 2, they're not connected. Oxygen to a hydrogen combined to an oxygen. 4 and 5, this hydrogen is connected to a carbon. So that can't happen. So it's 1 and 2. Intermolecular forces. So I should go over this term again. So this is between molecules. So a hydrogen bond is an intermolecular force. Covalent bonds are not, right? That is within the same molecule. So you have hydrogen bonds, base stacking, electrostatic repulsion. And ignore like the 5-point each stuff. That was when the test was pointed differently. Right, so I have a DNA sequence that goes GGAT. Sorry, I have a DNA sequence and my endonuclease recognizes GGATCC between the G and the G. Tell me what cuts, what numbers. So 1, 2, 3, 4, 5. So here's my GGATCC. I cut between the G and the G. So 5, 6, 7, 8. Making a cut right here. And then I don't see GGATCC again in the top strand. So I look at the bottom strand, looking for GGATCC. Here it is, GGATCC, cut between the G and the G. So 32, 33. So I make a cut between 7 and 8, 32 and 33. These are uneven cuts. So that'll lead to a sticky end. So that's what I was looking for there. Here's the answer for DDNTP. What factors make a plasmid viable for cloning? So these are the answers I was looking for. Ligase, PCR, again, the answers here. When determining if a protein is present in a sample, why do we use 280? So to give really points for this, you have to tell me the amino acids that were absorbing light. If you just answered because that's the frequency that proteins absorb light at, yeah, that's why it's in the question, right? That's what the question is asking, but it's saying why does it absorb light there? So cysteines form disulfide bonds. When lysine cells, what are 3 challenges? pH, temperature. So you have to keep the pH around 7. So buffer will do that. Temperature, too warm a temperature will denature your protein. So you need to keep it on ice. Enzymes that can destroy your protein. So you just add different reagents to stop those enzymes. You can also talk about contamination if you wanted to. So you just have to make sure all your equipment is sterile. GFP, cellular location or co-localization. Salting out. Salting out is increasing the salt concentration to make proteins precipitate out of solution. It has nothing to do with a cell. And this is just one of the ways we talked about in class, how to purify a protein. And that's pretty much it for test 1. If you have questions about why something is graded the way it is, you think you should have got more points, let me know. We can discuss that. Otherwise, that's all I had for you in this video. I will see you in the next one.